Assalamualaikum, what is up guys? Today we are going to learn about how to determine the coordination number and also the number of atoms per unit cell for phase center cubic. Right, so let's go. So this is our typical phase center cubic 3D structure. Just in the previous video we already talked about it. In order to determine the coordination number, we in my style we have to choose one target lattice point. So for this video I will choose this lattice point. So why this is important for us to choose one lattice point, because it will determine it will contribute to our um, drawing in the next on how to find the coordination number. So if we target the right side, right face center cubic of lattice point. So here we are. So our drawing must be like this. Because why? Because coordination number is, we actually want to calculate how many neighboring lattice points are there, which is excluding the target lattice point. So if we choose the other lattice point, it will become a different structure. So in this structure we can see that, well, it is a bit mess because 3D. So so we move back to our target here, which is which one is our neighboring atoms. So of course it is the same plane as the target, which is in the x plane, which is this plane. We have 1, 2, 3, 4. So we have 4 edges. So maybe we can do like this. Sorry, I should use the ruler. So we have already 4 neighboring atoms. So is that it? So no, because it also neighbors with the face lattice point of the neighboring side. So which is the back side of the first atom and the front side of the first atom, the back side of the second atom, the front side, the upper side, I forgot the upper side, and also the bottom side of the lattice point. So it's a bit mess, but we can because I already marked this, which is we have how many E. We have 4 E with 4 edges. So we have 4 plus with face 1, 2, 3, 4, 4 face, 4 faces, which is neighboring atom to neighboring lattice points. Sorry, to the our lattice point target, plus with the other 4 side face lattice point, which is 8 lah. 8. I'm sorry. So we will get 12. So the Cn of our FCC is 12. So let's move. Okay, we go back to this. In order to determine the atom per unit cell, we must imagine that each one of these lattice points enlarge into to fill up the space, just might bigger scale. How did it feel? Did it feel the cube the unit cell? So, but in my style, I would like to view it from the side and make it into a few portion, which is in the side we will look like this. Despite of this 4 is on the center of another plane lah, another plane. This is the front plane, and this you must note that the original is 3D. So yeah, this must be on the other plane, which is this the plane with this as the face lattice point. If we enlarge it, and note that I only make this into the portion of the lattice point, which is in real the packing factor must be touched in this side. So note again that this is only to determine the atom per unit cell, which is in my style I would like to do like this, and I would like to separate into a bit the proportion a portion. So if you look, the edges here is actually 1 over is a quarter, so quarter, so quarter, and the face, which is this is a face of the unit cell, which is half of the lattice point of the atom So half of the atom, which is half of the sphere, and a quarter of sphere is not 1 over 4. Instead it will be 1 over 8. So note that this is not a circle, but it is a spherical, because we are dealing with 3D drawings. So we have half for the face, which is for the face atoms, and quarter for the edge atoms. Right. Note that the cube have edges. How much edges we have? 8 edges. And we also determine that the each edges of the cube contains quarter of atom, which is 1 over 8. And we have 6 faces for the cube, which is cubic. And each of the faces we have half of an atom. So we calculate this. FCC number atom per unit cell is edge times with the proportion of atom in the edge, which is 8, will time with 1 over 8, plus with the faces times with the proportion of each faces, which is 6 times half, and we will get 1 plus 3. So 1 plus 3, we will get 4 number atom per unit cell. Alright, I think that's it. Thank you.